You're doing that. Okay. So yesterday we saw what is list, what is tuple, and we also discussed about couple of properties, right? Append and insert. Okay, so that is to add to the list. Now let's say, okay, somebody asked, right? I think Murli, you asked, right? What is the use of this, right? So let's say you want to, we did those program, right? Remember, input marks in 5 subject, right? Find average and grading, right? So first, what we did was we did M1 equal to int of marks, right? Int of input, right? Then we did M2, M3, M4, M5. Okay, sum was M1 plus M2 plus M3 plus M4 plus M5, right? This was your total, and you printed the total, right? Okay. I'm not doing other things because those things are not of interest to us. So if I say 50, 50, 50, 60, 60, okay, you get 270. Then we said, okay, we'll use for loop. Okay, so instead of saying input, input, input 5 times, what we did, we said, okay, let's input all the values using loop. So I'm going to say here for I in range 5 because we need to input 5 marks, and we said M1 equal to input, and then because we know that if you run this loop again and again, the value will be lost, right? So what we did, we said total equal to 0, and then here we said total equal to total plus M1, right? So this is how we used loops to read multiple values. Okay, so now if I say here 50, 50, 50, 60, 60, you get 270. All good. So advantage of using loop here is that, using one input, okay, we got multiple values, right? So overall, we saved at least 2-3 lines of code. But the disadvantage is we have lost the values. If I want to know what was the marks in first subject, you can't tell me because we have lost it. This is where you can use list to save the values. So I can create another variable called marks equal to blank list. Okay, blank list. Now, after reading M1, before doing total or after doing total, doesn't matter, but before the loop runs again, I will say marks dot append M1. So you can now say, okay, print marks obtained are, right? Marks, right? So now when you run it, okay, 50, 50, 50, 60, 60, you see, the values are stored. You can access. So this is how you can use. And it need not be 5, right? You can make it 500. Even though if you make it 500, all values will be saved, right? So this is the beauty of using append. Okay, this is where you can use append. Okay. Now, you have something called as data structure. Okay, data structure talks about how to handle different values. Okay, there are the way you will, let's say, you want to build um, you want to build a banking application. Let's say, for example, right, and you have certain object, certain block of code that you don't want multiple people to access. Okay, it will be first come, first serve basis, right? So let's say if I go like cinema ticket, movie ticket, okay? So you can have 5 people arriving at the same time, but what happens? So, okay, first person who goes to the counter will be able to buy the ticket first, then the second, then the third, so on, right? So we call it as first come, first serve, right? First in, first out. Okay. So that's, this is a situation where you will have first in, first out. We say FIFO. Okay. Those who came first will be the first one to go out as well. So this is one structure, right? This is one type of data structure. We call it as queue. Okay. Then there's another type of data structure called as stack. Okay. So let's say you go for this parties, right? Buffet or marriage parties. They'll have plates there. So there's already a plate kept there and you're about to take that plate. But what happens? That guy comes and puts more plate on top of that plate. Then the plate that you were taking went below, right? So what will you do? You'll take the topmost plate or you'll go down and take the plate, topmost plate. So here, the plate that came later is the first one that you're taking, isn't it? So it is last in, first out. Okay. Last in, first. The last one that came is the first one that you will take, right? Or we say stack of books, right? In general, we say stack of books. Now you have got a book, you kept a book at a table. Then you take another book, you put that another book on the top of that. So the first book that came, it went down and you keep on piling the book. And now if you have to pick up the book, you have to pick up the last book that came first, right? So we call those structure as stack. Now, some of these things can be used using list. Okay. We are not going to get into details of doing this, but just to tell you that there are different ways of implementing concepts, and that's where you will need insert. Okay. Now, tell me in which scenario out of LIFO and FIFO, where do you think that append will work? Hmm.
Probably FIFO, right?
In both the cases, right?
Oh, yeah.
In both the cases, whatever is coming is going behind, right? So, but while taking out, when we're doing remove, and that's the next part that we'll do, there it depends, okay? Should you use pop or remove, okay? But to add, okay, both the cases, it works well. But let's say, okay, you fix that, I probably have to use paint to demonstrate. Give me a second. Okay, so this is your queue structure, right? So first number that arrive will take this position. Second number will take this position. Third will take this position. And then you are going out from here. Stack is generally represented like this. Okay, first member will be here. Second member will be here. Third member will be here. Now, if you say that, no, I want to use um, like insert only to figure out that first member that goes will take the last position. The first member that is going is taking last position, not the first position. See, when you say 1, 2, 3, 4, then that's what append is doing. But let's say you say 6, 5, 4, 3, 1. That means last one should take the first position. Okay. So last one should take the first position. Then you have to do insert. Okay. So for example, I'll go back to our code again. Okay. So so this is one way. Okay, this is, let's say, queue kind of stuff. So for for this, we don't have to make any change. Okay, first in, first out, we don't have to make any change. But now if I have to handle the other way, okay, so here what I should do is, when the marks are getting added, okay, it should not be getting added at the last position. It should be getting added at the first position. So whatever comes becomes first and rest becomes second, right? If you have only one book, that book is first. But when second books come, first book becomes second and the last book becomes first. So you will say insert here, okay, and the index will be by default 0. That's when the newest member will be at first position. Newest member will be always as first position. So now when I run it, okay, now I can demonstrate both in same example, but let's take a different example. So, okay, so I say 50, 60, 70, 80, 90. 50, 60, 70, 80, 90. This is how you got, right? Now, if I enter same values again for this one, 50, 60, 70, 80, 90. Now you see, you got 90 at the first to go out. 50 went behind, right? So, depends upon your logic ultimately, right? But you can use these, ways of adding members to the list. Now, how do we remove it, right? Sorry. Yeah, we wanted to put in reverse order, right? We wanted this to go out first, 90. Last one should go out first. Here 50 will go out first, 60 second, 73rd. Here 90 will go out first. Stack. Last one to come will be the first one to go out. Right? So either you use remove to handle it, or you use insert or append to handle it. So in this case, I have used insert only to handle this. Going out is always from left side. If assume that going out is always from left side, so here 50 will go out first, but here 90 will go out first. That's why we say first in, last out, or last in, first out, LIFO. Okay. Then apart from that, you have, I said, right? So let's take this as our list L1. Now I need to remove this. So there are two ways to remove it. You have L1.pop. Now see, since list is mutable, all the operations that you're performing will apply on the list. So if you print list here, okay, you can see the change. But that was not the case in string. What we have to do is we have to print here itself. We have to print list here itself, we have to print. Because the original list value would not get changed. So if you print below, you will not see the result. But since list is getting implemented or getting impacted, okay, so it doesn't matter where you print, you will see the result, the action part will be shown. Make sense? Okay, so let's see this. Now, okay, so I'll wanted to show you the values also that takes. Pop, it does take index. Okay, so it takes position, which position you want to remove. Okay, so if I run it, what happens? By default, the last got added. Okay, now when I run it, okay, so last value gets removed by default. But if you don't want to remove, default is -1. Okay, Now I don't want to remove -1. I want to remove, say, first element. So what I'll do, I will say 0. Now when you say 0, see, 90 got removed. So pop works on index. Now if I say L1 dot remove, so it takes value here, right? So I want to remove 90. Okay, I want to remove 70, let's say. So I'll put 70. And then if you print L1, 70 is gone, right? If I want to remove 90, what should I do? I have to put 90 here.
Just, yeah, remove 90.
90? Sure?
Yeah.
You get
Oh.
error. X is not in the list. It's already removed, right?
Oh, it's already okay.
Yeah, it's removed using pop,
Pop, yeah.
right?
Mm.
No, sorry, thank you. So it's already removed using pop, right? So what you need to do is you need to check if this value is there or not. So you have in command that we've been using in for loop. In. So you'll say 90 in L1. L1, not Li1. Okay, 90 in 1. If this is correct, if this is true, so 90 in L1 will be true if 90 is present in L1. Otherwise, it will be false. So if 90 is present in L1, then you will say L1 dot remove 90. Otherwise, you will not do it. So now when you run it, you won't get error, right? Because this is false, so remove will not occur only. You can also use something called as find. Okay, L1 dot not find, count. Okay, this will tell you how many times the value exists. So if L1 dot 90 count greater than 0, that's when you perform remove. So when you're doing remove, you can actually check. Okay, and when you're doing pop, you check the length of the list. Then only you remove. Now if I say pop 10, index 10, is it there? No, you get error. Index out of range. Out of range. Range is what? 0, 1, 2, 3, 4. You can have only 4 maximum. Okay, anything more than 4 will give you error. So you can check here. If index to remove is 10, okay, so check if length of L1, okay, is greater than IDX. Why did I use greater, not equal to? Length will be more than the index, right? 1. If your value is 1, length will be 1, but index will be 0. So length should always be more than the index, right? That's why I have not used equal to, right? So if length is more than index, now when you run it, okay, so if in this case it's not removing because obviously index is greater than length, right? So this is how, these are the 4 important methods: append, insert, pop, remove. And we also saw count, right? Okay, then there's one. Okay, so let's take another list here, L2. Okay, so we have two important function which will help you to actually perform simple methods. So if I say sum of L2, okay, So it adds. So in the previous example, when we were doing the total here, you don't have to now create a total and keep reading the value. The example here that we did, right? We said total equal to M1. You don't have to do it. Okay. You can simply say, okay, now same example if I take here. Okay. You don't have to define total equal to 0. And you don't have to say total equal to total. Instead, you can say total equal to sum of marks. That's it. Okay. So now when I run it and I have to enter the marks 50, 60, 70, 80, 90. The total is 350. Okay. You don't have to use that variable to keep reading the marks. Okay. Sum will work. Okay. So this is about sum. Similarly, okay, there are a couple of more stuff. Let me put it here. Using some function to do total. Okay. Come back here. Let me remove all these things. We'll put it here. And I'll upload all these later. Okay. So L2 is this, right? We found some. Okay. So let me put this one also here. Okay. Now you can even reverse the list or you can sort the list. Okay. I will. Okay. So let's purposely make it unsorted. Like somehow it became sorted, right? Let's do this something like this. 90, 80. Okay. So now if you simply want to reverse the list, you can say L2 dot reverse. Okay. Now if you print L2, so see it got reversed. 70 was last, became first. 70, 50, 60, 90, 80. You can reverse the list. If you want to sort it, okay, you can simply sort the list. How do you sort the list? L2 dot sort. And when you sort it, okay, you see it's sorted in increasing order. Now, how do I sort in decreasing order? So if you want to do sort in decreasing order, you first sort it like this, and then you do the reverse, right? You do the reverse, right? Or you have an option in sort itself. Okay. Inside, as a parameter, we are passing reverse equal to true. By default, reverse equal to false. You say reverse equal to true, it will sort in decreasing order, right? So that's why, when you have numbers and these are the things that you have to perform, list is useful. You can do add, you can sort, you can reverse. Okay. So these are important functions. Now, there's one more important function which I want to do it before we end the list, is called as extend. Okay. Now, extend means, okay. Okay, so let's say we have L1 equal to 246 and you have L2 equal to 459, let's say. So if I perform L1 plus L2, okay, I need to create third list, L3, right? Where I can do L1 plus L2. And then I'll say L3. So you are actually using third list to add the previous two lists. Your L1 and L2 will remain as it is, and the value will go to third list. In numbers we have, right, sum equal to sum plus. When you say sum equal to sum plus means you are changing the sum value itself. So that's what extends does. So here if I say L1 dot extend L2, so it is now if I print L1, okay, so you see L1 is new value. So it is extend is like saying L1 equal to the one that is using extend. So L1 dot extend, right? So it's like L1 equal to L1 plus L2. So it's like saying L1 equal to L1 plus L2. This is how you do the extend. So, extend will add to the existing list itself, set of values. Okay. Okay. Now let's say that I create, we have L3, right? L3 is this 246459. Okay. Let me put this here itself. This is L3 value. Now I'll say L4 equal to L3. Okay. And I'll say L5 equal to L3 dot copy. So I'm creating L4, which is same as L3, and I'm saying L5, which is L3 dot copy. Now, if I print L1, sorry, not L1, L3, okay, and I print L4 and L5, what will be the values?
All the same values.
All the same values? Okay. L4, L5, you get all the same values. Okay, good. Now, what I'll do is I will add one value to each of these three. So L3 dot append 11, L4 dot append 22, L5 dot append 33. Now if I print L2, what will happen? After append. Okay. What happens? What happened? Tell me. See and tell me what happened.
L3 printed 11 and 22 as well as L4.
So what we added to L3 is in L4 also. What we added to L4 is in L3 also. Okay. So when you say equal to, right? When you say equal to, this is called as deep copy. Deep copy, and this is how you remember in your mind. Okay. You don't say this in the interview, but this is how you keep it. So this is like renaming. It's like having a duplicate name. Okay. And when you do dot copy, it is doing shallow copy. It's like taking a photocopy. Okay. See, the moment you take a photocopy, at that very moment, both will be exact replica. But after taking photocopy, you can go and make any changes to it. Yes or no? You can make any changes to it. After taking duplicate, after taking replica, you can do whatever on them. They will not be reflecting same value, right? So here I'm taking photocopy. So L5 and L3 are same. But after that, you go and scribble on it. It's not going to be reflected on other copy, right? But it's like L4 and L3 like giving same name. So they point to the same set of values in the memory, just that they have different name. Like you have pet name and official name, right? So whether I call you by your pet name or your official name, you're going to respond. You're the same person. So assume this is like that, your pet name and your official name. Okay. So it doesn't matter whether I say L3 do the job or L4 do the job. So L3 and L4 points to the same memory location, so they will have same value. You make changes to L3, L4 will have. You make changes to L4, L3 will have it. Okay, it doesn't matter what whom you call, both will reflect the same. Okay, so it's the same set of values being called by two different names. Okay, so if you're making changes, others will also reflect it. It will be there on the others also. Make sense?
Yes, sir.
So this is how, okay, list it works, and your copy and um, uh, equal to, deep copy and equal to works. Okay, this is possible only in the mutable stuff. So this works with list, but this will not work with tuple. Copy, it will not work with tuple, it will not work with string. It works only with list. And then we'll do dictionary, so it will work with dictionary as well. Dictionary is also mutable. Okay, so I'll give you an assignment here. I want you to try this. Assignment for this is, okay, write a program, of course using list, to read the marks of 5 subjects, okay, for 5 students, and marks of 5 subjects of 5 students, and find the highest marks for one each student, and for second each subject. Okay, so for example, okay, if you have read it, okay, now you see this here, we have 5 students and 5 marks, so you have to read as a list of list. Okay, and I'll show you the first part, and second part logic you have to do it. So here it will be, let's say, we will have set of marks for each student. So you have, this is for first student, second student, third student, fourth student, and fifth student. Let's say we have values like 44, 77, 66, 55, 88. Now there you have 64, 54, 74, 84, 94. 1, 2, 3, 4, 5, right? And this is for third student. Okay, 99, 66, 44, 77, 55. Then you have for fourth student. Okay, 8, 3, 7, 4, 6, 5, 5, 6, 6, 7, 1, 5, right? And then let's say last student. Last student is 81, 91, 81, 71, 61, 51. So what is the marks for each student? So this is marks of each student. Okay, so the for highest for student 1 is 88. For student 2 it is
94,
94. For student 3 it is
99,
99. For fourth student it is
83,
83. Fifth student it is
91.
91. Right? Now for subject. Okay, for 1 it is, let me remove each, right, so that it falls exactly below. It look this thing. Yeah. First subject 1, 44, 64, 99, 83, 91. You have to look at the first member of each list here. So then actual answer is 99, right? For subject 2, 77, 54, 66, 74, 81. So it is 81. Subject 3, 66, 74, 74, 44, 65, 71. So it is 74. Okay. So for fourth subject, 55, 84. So 84, right? 77, 56, it is 84. And fifth subject, 88, 94, right? So looks like 94 is the highest. So this is what I want you to print. Okay. This will test your logic. It's mostly test your condition and loop. Okay. And again, if you want me to do it, you have to first try and come to me, right? So how do you read the values of values? So I can say students, okay, empty, and I can say all marks. All marks is the main list. Inside that you have this smaller list. So what we have to do is, first we are building the student marks, and then we will add to the all marks. So I'll say for I in range 5 student, 5 subjects, right? And then I'm going to say here, this is going to be inside this. Now I'm going to say for J in range 5. So see, I'm reading inner loop will run 5 times and then append to the outer loop. Again, inner loop will run 5 times, add to the outer loop. Inner loop will run 5 times, add to the outer loop. So inner loop is running 5 times. That way I'm getting marks of each student. That's what I told, right? Marks of each student. So this is your student. So I'll say print, okay, or I can print here itself. Print marks for student, right? Now marks for student, okay. If I is 0 student, it is I plus 1, first student, right? So I can say something like this. So marks for student 1. Then you say, give me the subject. So int, or we'll say m, right? Okay, let's say marks m equal to int of input. I'm assuming marks is integer. You can use float as well, not a problem. Float will also work exactly the same way. Now, input takes only one value. Print, you can say comma, comma, but input you cannot say comma, comma. I'll say, okay, marks obtained in subject. Okay. Now here I have to say j plus 1. Plus 1. You're combining two string. Okay. Plus colon here. Now you see, is it a string j plus 1? No. So we are saying add string plus integer. It'll give you error. So I have to convert this into str. So str of j plus 1. So when you get this m, now we will create this student dot append. Dot append. So this m will go to the, okay, to the students. So once this is complete, once this inner loop is complete, we will append it to the main list students. So student becomes blank before entering again next set of values. So it adds to all student, goes back. Now I becomes 1, comes here, student is reset to blank list, so that we can start entering again 5 values. Okay. So what I'll do, let me copy this here so that, you know, Okay, so that when we run it, we can give exact same value and you can see. And once you are done, you can say print all marks something equal to all marks. Okay, now let's run this and see. So you see, marks for student 1, marks obtained in subject 1 is 44. Oops. List append takes exactly one argument, 0 were given. You have to say M right here. Okay, so subject 1, 44. Okay, 77, 66, 55, 88. Now, student 2, subject 1, 64, 54, 74, 84, 94. Student 3, subject 1, 99, 66, 44, 77, 55. Okay, subject 1, 83, 74, 65, 56, 67. Okay, student 5 is 91, 81, 71, 61, 51. Okay, so this is how you got all marks, right? Now, when you are doing the program, right, this algorithm assignment 1, okay, you try it once, okay, but you don't have to, do this again and again. Okay, what you do, you put all marks equal to like this, and then try to iterate with all marks. You don't want to, it's a waste of time again and entering. So don't, try to run this loop again and again. So you put all marks equal to like this, okay, and then you try to do your logic. So that your focus should be on the logic, not running it again and again manually. Once you are done with your logic, when you are happy with your logic, then you put first and second part together. Make sense, guys? Ankit, Karan?
Yes, sir.
Okay. So yeah, with that, we will stop our discussion on list. There's one important feature, okay, map filter reduce. For list, we'll do it once we come back from functions. So we'll do functions and then we'll come back here. So, okay, so that list portion, that is important. So we'll do that. And we can also do for loop and if condition in one line. Okay, so maybe I'll just do it tomorrow. Okay, I'll show you how to do one line for loop and else if. So if there is only one condition, you don't have to do it like the normal way that we have seen. You can even accomplish it in one line. We'll see it. Now, tuple, whatever we discussed yesterday, that is good enough. So tuple has how many methods? We saw 2 methods, count and index. Count and index is in list also. Okay, those are there to read the values from the list. Okay. Yeah, there's something called as clear. Okay, so now if I say all marks equal to this, I can, okay, let me move this away. Otherwise, I'll have to run 25 values. If you want to reset it, you simply say L3 dot clear. Clear will delete all the values that are there in L3. Variable will remain. So you will get L3, but it is blank. So clear will clear off everything. So with that, we complete our list discussion. We will now focus on next topic, which is dictionary. Okay. So let's just talk about introduction to dictionary. Okay, what is dictionary? So far we have seen 2 collections, right? So if I have to go and show you the different data types that we have seen so far. So we say collection or data types, okay? Data types in Python. Data types in Python. So it can be simple or basic. We call them as basic. Okay? Or complex or collections. That means you can have more than one value. So in basic, we have seen int. People consider str also as basic only. Int, float, okay, complex. These are your number, numeric data type. Then string, then Boolean. Okay. In collections, okay, then again you have linear and non-linear. Linear and non-linear. One dimension or multiple dimension. Non-linear. We'll do linear now, which is your list. We did tuple. Okay, we'll be doing set and we'll do dictionary. Non-linear can be multidimensional. So we'll do it later. Okay. After this, we'll do SQL. No, I mean, we have to do functions classes. After classes, we'll do SQL and then we'll come back again to Python and we'll do NumPy. Pandas. Okay. So these are the plan. These are the data types that we'll cover in our syllabus. Okay. So now let's go to dictionary and then we'll come to set. Okay. So how is dictionary different than list and tuple? So what is different between tuple and list? List is mutable, tuple is immutable, right? Collection is called unordered. Okay. So dictionary is a collection, right? Collection. It is linear. It is mutable. And we say it is unordered. If it is unordered, then how do we access the values? See, if it is ordered, we know first member, second member, third member. But if it is unordered, then how do we access the members? So dictionary gives its own set of ordering. It's called, dictionary is a collection of key value pair. So you see, so far in tuple and the list, we only saw value. We only saw value. But in dictionary, you'll also have key. Okay, so dictionary is given in this format. Okay, this is, just like list, it is represented as DICT. Okay, this is given as curly bracket. So we have used simple bracket for tuple, square bracket for list, and curly bracket, flower bracket we have to use for dictionary. So here you have key colon value. Key colon value. This is how we represent dictionary. So I'll give you an example. DICT1 equal to empty dictionary. Okay. So now if I print the type of DICT1, you will see it is a dictionary type, class dictionary. You can give a member. Now if I have to give a member, okay, I have to give, okay. One more thing you have to remember in tuple is, okay, when you're giving a blank tuple, T1 equal to, okay, if I say this and if I print the type of T1, what do you get? Tuple. Now if I have to add just one member, I'm adding one member, okay, or maybe 100 I'm adding, just one member to tuple. If you add one member to tuple, it is giving integer. Because in integer also we use bracket, right? Mathematical operation. So see, you cannot have a bracket in mathematics without any value in it. So if you have a bracket, then it is definitely a tuple. But when you have one value, it can be integer also, right? So when there is a confusion, it will give you the lower this thing. So it tells us it is integer. But I don't want it to be like integer. I want it to be like a tuple. So you give comma here. So only this thing you have to remember. So if you have one member in tuple, then you have to give comma. But if you have multiple values, then comma is not required. I mean, 100, comma 200, then you don't have to give comma in the last. See, if it is 0 also, you don't have to give. If it is 2 also, you don't have to give. It's only for exact one value you have to give comma. Just remember that. If you are declaring a tuple with exactly one value, you have to give comma, extra comma. Otherwise, you don't have to give comma. For 0 also, you don't have to give. For 2, 3, any number of values also, you don't have to give. Only for 1, because it doesn't know whether it is tuple or you are giving number in a bracket. I will assume that you are giving number in a bracket or string in a bracket. Okay. So if you have more than 2 values, no problem. But for exactly one value, we have to give one extra comma. Okay. This is about tuple, right? So this one point I missed. So we'll see that. Okay. Coming back to dictionary. So here you get type dictionary. And if I have to add values, I have to add values to dictionary, I can say dict1 equal to, okay, curly bracket, and now you give value. So 1:500 means what? Key is 1 and value is 500. There is no indexing 0 here. So if I have to read this 500, indexing is again same. The way we would do indexing of tuple or list or string. So I'll say print dict1 square bracket 1. No 0 here. The dictionary of 1 will give us 500. If you want to add one more value, now, okay, key can also be any value, any data type. I can say here string 2 colon, okay, Sachin Tendulkar. I can say some index colon 999. Okay, I can say city colon Mumbai. Okay, so you can give key, you have to give key colon value. So you can give any data type as key. And of course, value can be any data type. Okay, but you have to remember that key cannot be duplicate. I cannot say 1:500 and then again, oh yeah, 1:1000. So if I say 1, okay, it will always give you the latest value. So this value is you have just lost. So key should not be duplicated. Okay. Key shouldn't be duplicated. We'll stop here for today. So tomorrow we will see some functions that are there specific to dictionary. Any questions so far?
No, sir.
No? So yes. So as I've been saying,